For 400 years, we have pointed telescopes at Jupiter and called it the gentle giant, the friendly protector, the cosmic vacuum cleaner. We have been wrong. Jupiter is not peaceful. It is the most violent environment in our planetary neighborhood. Its radiation belts can kill an unshielded astronaut in hours. Its atmosphere crushes spacecraft into silence. Its gravity captures comets, tears them apart, throws objects across the solar system, and may have erased earlier planets before Earth existed. This is not mythology. This is physics. And the proof came in July 1994, when the largest planet in the solar system did something no human being had ever watched before. It ate a comet. On March 24, 1993, Carolyn Shoemaker, Eugene Shoemaker, and David Levy found what looked like a smudge on a Palomar observatory plate. But the smudge was broken. Not one object, 21 fragments. A chain of icy bodies stretched across space like beads on a string. The newspapers called it the String of Pearls. Its real name was Shoemaker-Levy 9. The comet was not orbiting the Sun anymore. It was orbiting Jupiter. That had never been seen before. On July 7, 1992, Shoemaker-Levy 9 passed inside Jupiter's Roche limit, the boundary where tidal forces overwhelm an object's own gravity. The comet could not hold itself together. The nucleus stretched, cracked, separated, and became 21 falling weapons. By May 1993, Brian Marsden at the Minor Planet Center announced the prediction. The fragments would hit Jupiter in July 1994. For the first time in human history, we knew the date of a planetary impact before it happened. Between July 16th and July 22nd, the fragments struck. One after another, every 7 or 8 hours, another piece of comet slammed into Jupiter's southern hemisphere at about 60 kilometers per second. Fast enough that ice became fire. Fast enough that impact became detonation. The total energy released was roughly 6 million megatons of TNT. Plumes rose up to 3,000 kilometers above the clouds. Dark scars larger than Earth spread across Jupiter's atmosphere and stayed visible for months. Shoemaker-Levy 9 was not an accident. It was a glimpse, a recorded frame of what Jupiter has been doing for billions of years, capturing, stretching, braking, executing. But the most lethal thing about Jupiter is not visible at all. Jupiter's radiation is not background danger. It is an environment, a machine. Deep inside the planet, hydrogen is crushed until it becomes metallic, electrically conducting, and moving. That layer generates Jupiter's magnetic field. And that field is monstrous. Jupiter's magnetic moment is about 20,000 times stronger than Earth's. The field rotates with the planet once every 9 hours and 55 minutes, dragging charged particles with it. If human eyes could see Jupiter's magnetosphere from Earth, it would look larger than the full moon, not the planet, the invisible cage around the planet. Earth's radiation belts are fed mostly by particles from the solar wind. Jupiter's are fed from within, by Io. Io is the most volcanically active world in the solar system. Its volcanoes release roughly 1,000 kilograms of sulfur dioxide into space every second. That gas becomes ionized. It becomes plasma. Jupiter's magnetic field captures it and turns it into a giant torus of charged particles wrapped around the planet. Then the field accelerates them. These are not slow particles drifting through space. They are microscopic bullets, subatomic shrapnel moving at near light speed. Standing near Jupiter is like standing inside a particle accelerator while someone turns it on. The human consequence is simple. A whole body dose of about 5 sieverts is fatal to most adults within 30 days. Near Europa, an unshielded astronaut could receive a lethal dose on the timescale of hours. Closer in, faster. The first symptom might not be pain, it might be light. Flashes inside closed eyes, as high-energy particles cut through the fluid of the eye and produce Cherenkov radiation inside the body itself. By the time you see the warning, the damage has already begun. The Galileo orbiter discovered this slowly. It arrived at Jupiter in 1995, designed for a total radiation dose of about 150 kilorads. By the end of its mission, it had absorbed roughly 4 times that. Its star trackers saw false stars, its gyroscopes degraded. Galileo did not simply fail, it was worn down, poisoned. Then, on September 21, 2003, NASA deliberately sent it into Jupiter to prevent contamination of Europa. We did not lose Galileo, we watched Jupiter execute it. Juno survives only because it was built like a spacecraft hiding inside a bunker. Its central electronics sit inside a titanium vault, about 200 kilograms of shielding that reduces radiation exposure by a factor of about 800. And even then, Juno does not live in the worst of Jupiter. It flees. It flies polar orbits, skimming danger, then escaping millions of kilometers away. Juno is not exploring Jupiter casually. It is engineered to outrun the place it studies. But Galileo did something even more violent. It dropped a probe built not to orbit Jupiter, but to fall into it on purpose and keep transmitting until the planet killed it. On December 7th, 1995, at 22:04:44 Universal Time, the Galileo atmospheric probe entered Jupiter. Its speed was 47.4 kilometers per second. That is 170,700 kilometers per hour. Mach 50. There was no surface waiting below it. No ground, no ocean, no landing. Only atmosphere becoming pressure, pressure becoming heat, and heat becoming annihilation. Within the first minute, the probe reached peak deceleration. 228 Gs. A human body begins to fail far below what Galileo endured. The probe took 228 times Earth gravity and lived for a minute. Its heat shield was carbon phenolic. The surface temperature rose to about 14,000 degrees Celsius, roughly twice the temperature of the sun's visible surface. In less than 2 minutes, the shield lost about 80 kilograms of its 152 kilogram mass. More than half of it boiled away into plasma, so the instruments behind it could keep speaking. At about 5 minutes, the probe slowed below the speed of sound and deployed its parachute. It began transmitting to the Galileo orbiter, 210,000 kilometers overhead, and what it found was not calm. It fell through ammonia ice, ammonium hydrosulfide, and deeper water cloud regions. Wind speeds climbed from about 80 meters per second near the cloud tops to around 200 meters per second deeper down, and they stayed there. That was the terrifying discovery. On Earth, weather is mostly powered by sunlight. On Jupiter, the winds continue where sunlight cannot reach. The engine is underneath. Jupiter is still releasing heat from its own formation, still slowly contracting under its own gravity, still powering weather from below. This planet has no surface, no continents, no ocean boundary where energy runs out. It is atmosphere all the way down until the word atmosphere stops being useful. Later, Juno would discover lightning unlike anything on Earth. Some flashes are superbolts. Others form in shallow clouds because ammonia acts as antifreeze. Even Jupiter's lightning cheats the rules we learned on Earth. At 58 minutes, the probe was about 150 kilometers below the entry interface, at 22.7 bar and 153 degrees Celsius. Its transmitter overheated. The signal stopped. The mission requirement was 10 bars. Galileo more than doubled it. For 58 minutes, it survived the most violent atmospheric entry ever endured by a spacecraft. Then Jupiter took it. But the probe did not stop falling when we stopped hearing it. It kept descending, melting, breaking down, and mixing into the atmosphere. Below that point, we leave measurement and enter models. About 10,000 kilometers beneath the cloud tops, pressure reaches around 140 gigapascals. Temperature reaches thousands of Kelvin. Hydrogen no longer behaves like the gas we know. The molecules dissociate. Electrons move freely. Hydrogen becomes metallic, electrically conducting, more like copper than air. About 3/4 of Jupiter's mass may exist in this state. That layer powers the magnetic field. That field powers the radiation. And that radiation kills spacecraft. The violence is connected. The storm above, the metallic ocean below, the particle accelerator around it, they are one machine. At the center, Juno found something stranger. Not a clean core, but a fuzzy one, with heavy elements diluted across a huge fraction of the planet. One explanation is brutal. Early in Jupiter's life, it may have been struck by a protoplanet about 10 times Earth's mass. Jupiter did not just form. It may have swallowed a planet while becoming itself. And above all of that, on the face we show children in textbooks. One storm has been raging longer than modern nations have existed. The Great Red Spot looks familiar because we have seen it too many times. Familiarity is anesthesia. In 1879, the storm stretched about 41,000 kilometers along its long axis. 3 Earths could fit across it. By 1979, when Voyager 1 passed Jupiter, it had shrunk to about 23,300 kilometers. By 2024, it was about 14,750 kilometers wide. Still enormous, but smaller than it used to be. The Great Red Spot is shrinking by hundreds of kilometers per year, and as it shrinks, parts of it are getting faster. Hubble observations from 2009 to 2020 showed that the storm's outer high-speed ring accelerated by about 8%. Some recent measurements put winds near the edge at roughly 640 kilometers per hour. The center is calmer, the rim is violence. For a long time, people said the Great Red Spot was more than 350 years old, connecting it to the permanent spot observed by Giovanni Cassini in 1665. But recent research suggests something more unsettling. Cassini's spot may have disappeared. The current Great Red Spot may have formed later in the early 19th century. Not 350 years old, maybe about 200. That means Jupiter can create Earth-sized storms and keep them alive for centuries. And the storm is not just wide, it is deep. Juno gravity measurements suggest the Great Red Spot extends about 300 kilometers below the cloud tops, with an upper limit near 500 kilometers. Earth's weather layer is roughly 10 kilometers thick. The Great Red Spot reaches at least 30 times deeper than the weather layer of Earth. On Earth, hurricanes weaken on land or away from warm water. Jupiter has no land, no shore, no final boundary. There is nothing for the storm to grind against, so it persists, fed by jet streams, fed by internal heat, fed by a planet that radiates about 1.6 times more energy than it receives from the Sun. Jupiter is not warmed mainly from outside. It is still hot from its birth, still contracting, still converting gravity into heat, still turning that heat into weather. Recent Hubble observations show the Great Red Spot pulses over about 90 days. It squeezes in and out like something alive. Not alive, never alive, but dynamic, restless, a storm with no ground beneath it. A storm with centuries behind it, and maybe not many centuries ahead. That is what Jupiter does to itself. But what it does to everything else is even more important. Because Jupiter's gravity does not stop at the clouds. It reaches across the solar system, and it is not only a shield, it is a weapon. The comforting story says Jupiter protects Earth. That story began with a truth. In 1994, George Wetherell showed that Jupiter can eject long-period comets from the solar system. Shoemaker-Levy 9 struck Jupiter the same year, and the image was irresistible. Jupiter, the bodyguard. Jupiter, the shield. But the solar system is not that simple. Later simulations showed that Jupiter is a dual actor. For some long-period comets, yes, it protects us. It flings them away. But for other populations, Centaurs and Jupiter family comets, Jupiter can increase the risk to Earth. It takes objects that would never have come near us and throws them inward. For asteroids, the effect is not a clean shield at all. Sometimes Jupiter deflects danger. Sometimes Jupiter creates it. The planet is not a guardian. It is a gravitational engine. A massive body rearranging traffic, indifferent to what survives. And it has been doing this since the beginning. In the Grand Tack model, Jupiter formed farther out, migrated inward toward the region where Mars orbits today, then reversed course when Saturn caught up. Attack, like a sailboat turning in the wind. Except the sailboat was 318 Earth masses, and the sea was full of unfinished planets. Imagine foundations being laid for houses. Now imagine a wrecking ball swinging through the construction site for millions of years. When it finally leaves, you do not get the neighborhood that was planned. You get whatever can be built from rubble. That may be our solar system. Jupiter's migration can help explain small Mars, the mixed asteroid belt, and why Earth may have received water-rich material from colder regions. Without Jupiter, Earth may not have oceans. Without Jupiter, Mars may not be Mars. Without Jupiter, the asteroid belt may not look the way it does. Without Jupiter, the architecture of the inner solar system does not look like this. And some hypotheses go further. Jupiter's early migration may have destroyed an earlier generation of close-in rocky planets, dragging debris inward toward the Sun. If that model is right, Earth is not the first Earth our solar system tried to build. It is the second attempt, built after Jupiter cleared the first one away. Even now, Jupiter is still sculpting worlds. Io is trapped in resonance with Europa and Ganymede, letting Jupiter flex the Moon up and down by as much as 100 meters every orbit. Rock bends, friction becomes heat, heat becomes magma. Io releases around 100 trillion watts of internal power. Volcanoes, lava lakes, sulfur plumes, and a surface kneaded by gravity until it burns. Jupiter does not need to touch something to destroy it. It only needs to hold it. Jupiter is 318 Earth masses. That is the textbook fact. Here is the better one. Jupiter is about 2.5 times more massive than all the other planets combined. Put Mercury, Venus, Earth, Mars, Saturn, Uranus, and Neptune on one side, Jupiter on the other, and Jupiter wins by a factor of 2.5. Its diameter is about 143,000 kilometers. Its volume could hold more than 1,300 Earths. It spins once every 9 hours and 55 minutes, faster than any other planet. But the most unsettling scale fact is not about Jupiter's size. It is about the Sun. The Sun and Jupiter orbit a common center of mass, a barycenter. And for the Sun-Jupiter system, that barycenter lies just outside the Sun's surface. The Sun is not exactly at the center of its own solar system. It wobbles around an empty point in space, dragged there by Jupiter. It has been doing that for 4.5 billion years, and still, Jupiter is not almost a star. It would need about 80 times more mass to fuse hydrogen. It would need about 13 times more mass to fuse deuterium. Jupiter was never close. It is not a failed star. It is something else, a planet pushed to an extreme. Adding mass would not simply make it larger. Beyond a certain point, pressure changes the rules. More mass can make such objects compress. Jupiter is already a world where gravity is an architect, a furnace, a crushing mechanism. The planet is still shrinking by about 1 millimeter per year. That sounds harmless. It is not. Across a body this large, that slow contraction releases enormous heat. Enough for Jupiter to radiate more energy than it receives from the Sun. It is still cooling from its birth, still collapsing slightly, still powering storms from within. And around it, Jupiter keeps a kingdom. More than 95 confirmed moons, Trojan asteroids, irregular satellites captured from elsewhere. A miniature solar system moving around one planet. All of them exist inside the influence of a body so massive it makes the Sun move. This is the thing we have been calling gentle. Jupiter is not gentle. It is not malicious either. That matters. Jupiter does not want anything. It does not hunt. It does not choose. The predator language is a metaphor, and the physics is worse than the metaphor, because intention would make it smaller, comprehensible, a monster in a story. Jupiter is not a monster in a story. It is a planet, a consequence of mass, rotation, chemistry, pressure, magnetism, and time. And that is why it is terrifying. The universe does not need hostility to be lethal. It only needs indifference. Jupiter's radiation belts can kill in hours. Its atmosphere can burn, crush, and dissolve machines. Its storms reach deep below the clouds. Its gravity has captured comets, tortured moons, and reshaped the worlds around us. And yet, without Jupiter, Earth may not have water. Without Jupiter, Mars may not be small. Without Jupiter, the asteroid belt may not look the way it does. Without Jupiter, there may be no us. We do not exist in spite of this giant. We exist because of it. That is the uncomfortable truth. The planet that can fling death inward may also have delivered the ingredients for oceans. The gravity that destroys orbits may have made ours possible. The next time you see Jupiter in a textbook, or in a museum, or in a child's bedroom poster, remember what you are looking at. Not a peaceful giant, not a simple shield, not a failed star. A world that never stopped burning with the heat of its own formation. A planet massive enough to pull the Sun around an empty point in space. A gravitational architect that may have destroyed worlds before giving us this one. For 400 years, we called it peaceful. We were not paying attention. If you enjoyed this video, consider subscribing, and I'll see you next time.